Here's a analog module. Right? Analog module setting is very simple. It's the analog input voltage and voltage output. For example, just double click. No program is required. So program, channel enable. For example, I will use channel 0. Enable, input range. I select 0 to 10 volts, for example, and the range is 0 to 16,000. So if 5 volts is applied, the value would be 8,000, just half. But you can select it in 4 types, 0 to 16,000 or -8 to 8,000, and precise scale the value, or even percentile, right? But in this case, 3 and 4 is the same. But if this input is like this, they're different, right? And this one is a 10,000 times scaled up value, and this one is a percentile, right? But in this case, select it simple like this, right? And we have filter process and averaging and blah blah blah. We have this is input module, and now we are going to have output. Output module, the same enable. I will set the same. Output module is like this. When you apply, it gives a value to 5,000 in some special area. Then this, this 5,000 corresponding analog voltage would be made to the real output channel. So if I put 5,000, then 5 volts is applied to the sensor, right? 6,000, 6 volt. So that's for analog stuff. And after that, finish.
Why don't you have to 100%?
It's the same. For example, if I set this, if you key in 16,000, 10 volts is made, right? If I change this, the same, or this one 1,000 times, and percentile. Well, for example, if in this case, 10,000 applied to 10 volts, 0 minus 10 volts.
10,000%.
No, it means, wow, it gives you kind of 0 digit, 0 digit, right? 14 points, 0 digit more, which means it's not 10,000, it's not 10,000%, but 100.0. So it's a precisely, you can, actually there's no digit, no digital.
It doesn't really matter.
Yeah, right.
When you put the object on the screen, just say,
yeah, it's like
100%.
Yeah, it's like it's like for example 9,500, which means 95%. It gives you more in the resolution, right? Okay, right. So after this, that's all for analog setting. And the next question. Input is very simple. Whatever happens in input, it does not affect the real output, because input means no instrument. Okay? Output is important. Output means something to be changed by controlling or applying some values. Right? So output is important. This one, input is just a monitoring. So even analog input module, the value is updated. Even PLC mode is installed. You are able to do that. The module is updated, but analog output is important. What if analog output is? You have to turn special output enable channel bits. After that, the output is made. Right? Kind of trigger. You have to turn on the trigger bits for output channel. There is. For example, now I put 5,000 after enabling some trigger bits. Then 5 volts is applied, right? Now for the output channel there is a 5 volt, correct? Then what if the PLC mode is stopped, or the trigger bit is turned off? Does it hold 5 volts, or does it go to 0? You are able to decide here. Follow value means when there's some problem occurred in the PLC output channel enabling bit, it stays. withhold previous value. Minimum value equals to 0 when the trigger enable bit goes wrong, right? Or maximum, or minimum, or in the middle. Usually it stays. Anyway, let's go. And after this, and then if you have this stuff, you will have this message automatically. But previously I said no, but I automatically, manually you have to insert this file, this value. So you have use device, which means universal. Well, let's do it. So I have this value and this value. So first of all, I want to read the values for the analog, for example. So analog means analog. You don't need to, for example, F99 always on, and move data. Analog input module, channel 0 output. Okay. The first channel, this is output value, digitalized value, to D0. Simulation. Now I'm doing simulation. So now this was analog input module, channel 0. So the channel 0 is 0 to 10 volts, right? 0 to 10 volts is changed to the digitalized as 0 to 10,000, correct? Right? Now it's a 0. Now the motion value is 0, which means 0 volts, correct? Okay. So I will change this analog here. Analog input A channels. Start channel motion. This one is 2. Change the voltage. Now 5 volt, right? 5 volt. Then see 5,000.
You change that from ladder as well, just by clicking?
No, this is monitoring.
Okay.
So what I changed here is, this is PLC, and there's a kind of analog in the voltage applied to the channel.
Okay.
Ladder logic I cannot change because it's the motion value. So you have to change this output value. So here, that is output. So I apply 5 volts to the here. That is changed. Okay. Right? So I change 4.1 to 3. Right? By this, this value. That's for analog input. Right? So let's say this is input, 5 volt is applied here. Then the value is 5,000, right? So this 5,000 digitalized value, I move it to some special address to make output, channel output to analog. Then 5 volt is made to the output. Which means I want to connect this D0 to make the output for the what if I say move this data, analog output module, as channel 0 input. To make analog output, you have to input some digital value. That is the space, that is the special area to make analog output for channel 0 in slot number 3. Like this. Okay. So you understand this, correct? Because here the voltage is 4.123 volts applied, you see 4,000 stuff, right? So to make an output, doing more I can't see this.
Much more to go, Brian.
Okay, it's almost finished. Okay. N0. Here you will see channel 3 output enable. This bit. That's for the program. So, right? Look here, for example. I applied 5 volts, right? So here 5 volts is applied, and the value is 5,000. So I move it to 0, which means, and also I just key in 5,000 value to some area to make analog output, 5 volts, right? Then the output should be 5 volts, right? But it's not that way because this bit is not turned on.
Yeah, just simulate it.
Sure.
Well, it's
Okay, right?
It's a bit of just showing customers what you can do with
Yeah,
it.
right. Here, let's say channel 3 is 0, right? But if you turn this bit on, turn this bit on 5 volt. When you input 4 volt, the output is 4 output. But unless this bit is turned on, then it stays formal value. It stays. So I change this value 6, stay 4. Because I said it's formal value. Right? That's it. So if I turn this bit on, 6 volt, right? Turn this bit on, output is properly applied to 6 volt, right? That's for analog.
So essentially you're trying to calibrate, you can actually force mid-scale. With 0 to 10 volts, you can force 5 volts on it.
Yes.
And you know that it has to be mid.
Absolutely.
Plus, if you're doing simulation,